In question we are given k distinct divisors of positive integer and that sum of those distinct divisors is 93 and summation 1 by xi is 93 by 50. Now just multiply with n on both sides. You also know that n is always greater than equal to its divisors. Equality when divisor is itself the number. And also n by xi is always a natural number. So you can say that sum of this n by xi is always a integer. Positive integer is equal to 93 n by 50. Now this n must be multiple of 50. Say 50p and p is natural number. So our n can be 50 or 100 or 150 and so on. Now we are given that sum of its divisors is 93 and you know that 100 has the number itself as its divisor. So only possible divisor, only possible number is 50 because if you say 100 as the number n, then this cannot be less than 100 because 100 would be divisor of 100. So this must be greater than 100 for numbers ahead of 50. So our n is 50. Now you need to find total number of divisors of 50. You can write 50 as 2 square, sorry 2 into 5 square. Okay, so the divisors would be 1 plus 1 into 2 plus 1. So total 6 divisors are possible. So answer for k is 6. Now we will talk about proof from which we can write for a number 2 raised to a 3 raised to b as the number of divisors of it to be a plus 1 into b plus 1. So let us talk about the proof. Let us take a number 36. We write this as 2 square into 3 square. These must be prime numbers, okay? And now you have choices here to choose 1, 2 or 4 for 2 square and you have choices here to choose 1, 3, 9 for 3 square. So our divisors could be 1 into 1 or 1 into 3 or 1 into 9 or 2 into 1, 2 into 3, 2 into 9 or 4 into 1, 4 into 3, 4 into 9. So these are total possible 9 divisors. That is like saying 3c1, 3c1. So this gives me 9. That is how we write here a plus 1 into b plus 1 for any given number with base as prime numbers. Now these must be prime numbers. I will tell you what might happen if you choose a number say 2 square into 4. You should actually write it as 2 raised to 4. But let us see what happens if you solve it this one. You might say it as 3c1 into 2c1 and get 6 as answer, which is wrong. So why it is wrong? So 2 square and 4, let us see. Here you can write it as 1 to 4 and here you can write it as 1 or 4 as possible factors of this each. Now you have to choose 3c1, 2c1. But when you do so, if you choose one number among this as 1 and one of numbers among this as 4, you get 4 as multiplication. But if you choose here 4 as a number and from here 1 as a number, you again get 4. So this is overcount and thus it is wrong. So you have to subtract this overcount from it. So our actual answer would be 6 minus 1, that is 5. And if you see from 2 raised to 4, you will again get 5's answer, that is 4 plus 1. So basically, to avoid this overcounting, we should always write it as prime number raised to some power format.